Good morning, dear participants. Let me introduce our paper, Classification System based on Ensemble methods for solving machine learning tasks. Introduction. Rapid development of machine learning technologies has initiated development on few methods and algorithms that more effectively solve data mining and forecasting tasks. The main feature of modern machine learning methods is not a direct solution to a problem, but learning from a set of examples, which allow these methods to be adapted to solve specific problems of processing large amount of data and discover new knowledge in them. To build an ensemble, several techniques are used to aggregate the results of underlying models, each of which provides a different accuracy. Bagging, boosting, and stacking are the most common approaches to build ensembles. The use of ensemble methods in solving classification problem is an effective way to improve classification accuracy. And problem stated, the purpose of this paper is to study ensemble methods for solving classification problems and to develop a classification system based on a two-level ensemble of models. The main idea of ensemble classifier is that they work better than their components when the base classifier are not identical. A prerequisite for the usefulness of the ensemble approach is that the base classifier must have a significant level of disagreement, which makes error independent of each other. The limitation of homogeneous ensemble frameworks can be overcome by using heterogeneous ensemble frameworks. Creating an ensemble is usually a two-step procedure. A set of base models are generated by running different learning algorithms on the training data, and then generated models are combined into ensemble. Structure of a two-level ensemble for solving classification task. To solve the forecasting task, a two-level ensemble learning structure was proposed as shown in figure 1. The ensemble structure consists of a base model training unit and a two-level ensemble training unit, each of which interacts with a model quality assessment unit. The models with high bias are selected for the first level of ensemble learning, and the models with high variance are selected for the second level of machine learning. Dataset description and preprocessing. Two datasets were used to create a classification system based on model ensembles: e-commerce shipping data and airflow self-noise dataset. The first dataset contains information about shipping data obtained from international e-commerce company. And the purpose of classification is to identify factors associated with the risk of late delivery of pre-orders to customers. The second dataset, airflow self-noise dataset, was designed to study aerodynamic properties of materials, and the resultant value is scaled sound pressure level in decibels. Data preprocessing includes checking for missing observation, non-numeric and anomaly values, converting categorical data into numeric data, selecting features and normalizing data. The check reveals that there are non-numeric or missing values in any attribute in the dataset selected for research. The interquartile range method was used to check the dataset for anomaly values, and it was found there is no outliers in the dataset, and factor variables are converted to numeric variables. And to solve the binary classification, an additional binary variable was created instead of a dependent variable. It takes the value of 1 if the dependent variable is greater than its own median, and 0 if it's less than its own median. The data preprocessing steps for the second dataset are the same as for the first dataset. And quality metrics for classifier. Accessing the quality of classifier plays an important role in the building and selecting classification models. And many quality metrics are used in machine learning tasks. For example, accuracy, kappa statistic, sensitivity, specificity, precision, recall of measure, and area under the receiver operating characteristic curve. The most common performance metrics take into account the model's ability to distinguish one class from the other. In this case, the class of interest called positive, while the other are called negative. The relationship between positive and negative class prediction can be represented in the form of a discrepancy matrix, which shows whether the prediction belongs to one of the four categories: true positive, true negative, false positive, and false negative. And the result of classifier work, the main advantage of two-level ensemble is the systematic use of ensemble methods and selection of base classification models for each level of ensemble learning. In the block of the training, the base model, the following models were selected as basic classification models: decision trees, naive Bayesian classifier, linear discriminant analysis, quadratic discriminant analysis, logistic regression, support vector machine, nearest neighbor method, artificial neural networks, and random forest model. Most of the models have satisfactory performance, but the results need to be improved as the company seeks to improve its sales and delivery services. Therefore, a two-level ensemble model is built to improve the results. As input data, the test score of the basic models are selected and added to the test set. In two-level ensembles, learning blocks stacking and bagging are used sequentially. At the first level, the stacking method is based on logistic regression model. Model stacking is an effective ensemble method. The forecasts generated by the base models are used as an input for training at the first level. Thus, the basic models of the first level are decision trees, naive Bayesian classifier, linear analysis, logistic regression, nearest neighbor method, and artificial neural networks. The second level is the Bayesian method using on bagged cut algorithm. One of the disadvantages of bagged trees is small number of additional training observation, and this can dramatically change the prediction performance of the trained tree. And the base model of the second layer as follows: the first level models taking logistic regression, random forest model, quadratic discriminant analysis, and support vector machines. Table 1 shows the values of performance indicators for the first data set. This data take into account the model's ability to distinguish one class from another. The data in table 1 shows the decision trees and quadratic discriminant analysis method have the best specificity and accuracy scores, while the decision trees have the highest precision. The F measure has the highest value for the random forest and linear discriminant analysis results, and the area under the rock curve is the largest for the classification results using decision trees. In general, the baseline classifiers performed in average on this dataset and need to be improved, and the artificial neural network generated the worst results. By making use of stacking to combine the 6 results of baseline classifier, the overall results is improved. Bagging to combine 3 results of the basic classifier and the result of the first level model stacking significantly improved the overall result for all evaluation metrics. Thus, at the first stage, combining some basic models, the accuracy was increased to 70%. At the second stage, combining some basic models and the stacking model into ensemble model using bagging increased the model accuracy to 88%. Table 2 shows the values of classification error rates for the model in dataset 2, which are necessary for the correct selection of base model for the first and second level of ensemble learning. And table 3 shows the values of performance indicator for the second dataset. For the second dataset, at the first stage, combining the basic models increased the accuracy to 77%, and at the second stage, combining some basic models and stacking model into an ensemble model using bagging increased the model accuracy to 82%. Thus, the use of two-level ensemble increases the efficiency of classification models. And conclusion, the general structure of a two-level ensemble was developed based of the use of two-level ensemble learning structure in the processing of two datasets. The classification quality was improved. Based on analysis of metrics for accessing the quality of base classifier, it was determined that they need to be improved. A two-level ensemble scheme is used for improvement. At the first level of the ensemble, stacking was used to reduce the bias of the base model. This approach resulted in preliminary improvement of classification quality. At the second level, bagging was used to reduce the variance of base model. Thus, the use of ensemble-based classifier solved the problem of finding compromise between bias and variance, which improved the classification result using machine learning model. Thank you for your attention.